Glycolysis is the sequence of 10 enzymes catalyzed reactions that converts glucose into pyruvate with simultaneous and production of ATP. In this oxidative process, 1 mole of glucose is partially oxidized to 2 moles of pyruvate. This major pathway of glucose metabolism occurs in the cytosol of all cells. This unique pathway occurs aerobically as well as anaerobically and doesn't involve molecular oxygen. Glycolysis comes from a merger of two Greek words, glykis sweet and lysis breakdown or splitting. It is also known as Embden-Meyerhof-Parnas pathway or MPT pathway. And this is the major pathway of glucose utilization. And we have two phases of glycolysis. Glycolysis leads to breakdown of 6C-glucose into 2 molecules of 3C-pyruvate, with the enzyme catalyzed reaction being bifurcated or categorized into two phases. Phase 1 is preparatory phases and phase 2 payoff phases. Preparatory phase, it consists of the first step of glycolysis in which the glucose is enzymatically phosphorylated by ATP to yield fructose 1,6-biphosphate. This fructose 1,6-biphosphate is then split in half to yield 2 molecules of 3-carbon containing glyceraldehyde 3-phosphate or dihydroxyacetone phosphate. Thus, the first phase results in cleavage of the hexo chain. This cleavage requires an investment of 2 ATP molecules to activate the glucose mole and prepare it for its cleavage into 3-carbon compound. The payoff phase naman is this phase constitutes the last 5 reactions of glycolysis. This phase marks the release of ATP molecules during conversion of glyceraldehyde 3-phosphate to 2 moles of pyruvate. Here, 4 moles of ATP are phosphorylated to ATP. Although 4 moles of ATP are formed, the net result is only 2 moles of ATP per mole of glucose oxidized, since 2 moles of ATP are utilized in phase 1. Phosphorylation, glucose is phosphorylated by ATP to form sugar phosphate. This is an irreversible reaction and is catalyzed by the hexokinase. Thus, the reaction can be represented as follows. Step 2 is isomerization. It is a reversible rearrangement of chemical structure of carbonyl oxygen from C1 to C2, forming a ketose from the aldose. Thus, isomerization of the aldose glucose 6-phosphate gives the ketose fructose 6-phosphate. Step 3, phosphorylation. Here, the fructose 6-phosphate is phosphorylated by ATP fructose 1,6-bisphosphate. This is an irreversible reaction and is catalyzed by phosphorylation enzyme. Breakdown. This 6-carbon sugar is cleaved to produce 2 3C molecules glyceraldehyde 3-phosphate GAP and dihydroxyacetone phosphate or DHAP. This reaction is catalyzed by aldolase. Isomerization, dihydroxyacetone phosphate is oxidized to form glyceraldehyde 3-phosphate. This reaction is catalyzed by triose phosphate isomerase enzyme. 2 molecules of glyceraldehyde 3-phosphate are oxidized. Glyceraldehyde 3-phosphate dehydrogenases catalyze the conversion of glyceraldehyde 3-phosphate into 1,2,3-biphosphoglycerate. These are the overall balance sheet of glycolysis. Each molecule of glucose gives 2 molecules of glyceraldehyde 3-phosphate. Therefore, the total input of all 10 reactions can be summarized as glucose plus 2 ATP plus 2 Pi plus 2 NAD plus 2 H plus 4 ADP. Those the isomerization reaction involved in glycolysis are glucose is oxidized to pyruvate NAD is reduced to NADH. ADP is phosphorylated to ATP. And this is the end of explaining the glycolysis. I hope you understand and have a blessed day.